Hi Math 95. I'm sorry it took so long. I'm finally getting around to doing this video with the rest of the examples from chapter 7 notes. So if you need a little extra time to get the homework and test ready this week because I'm so late with this, just let me know, okay? But we're gonna look at that, and so let me share my screen. I have somewhere in here, let's see if this is the right one. Okay, so what I really want to do is switch to this. Okay, so hopefully you can see that. The notes, so this is after that page, this is page 3, so this is after those rules we did in class. Okay, this is a PDF, so it's not showing what we did in class, but these are these practice problems here on page 3, right? So have this new little tablet righty thing, so we'll see if this works on here. All right, so remember that we have those rules. The rules were the product rule, so if we're multiplying expressions that have the same base, we'll add the exponents. If we're dividing them, we will subtract the exponents. That's a quotient rule. We also had the product, we had the 0 power rule, which means anything to the power 0 equals 1. We had the negative exponent rule, right? So we kind of just flip from the top to the bottom to make an exponent positive to negative or vice versa. And then finally we had the power rule. So if something is raised to a power, all of those inside exponents get multiplied by that outside one. All right, so here we have two expressions. Nothing is being raised to a power. There's no exponent outside that, right? So we're just going to go ahead and multiply. We can multiply the plain old numbers first. So 6 times 3 would be 18. And then I have A and B here. Remember I suggested that we put a 1 in wherever there's not an exponent. So A to the first times A to the third. I'm going to add those exponents. I get A to the fourth. B to the first times B to the negative fourth. 1 plus negative 4 is negative 3. I've simplified all of those, but remember this says to always write your answers using only positive exponents. Okay, so we want to rewrite it. 18 is going to stay where it is. It's 18 to the first power. A to the fourth is going to stay where it is, and B to the third will go on to the bottom. Okay, so hopefully what I would like you to do is try each of these on your own, and then check your answers here. Okay, don't just go through it with me, because then you're not gonna, when someone else is doing it with you, you kind of get the gaps filled in, right? So if you try it alone, you'll know where that problem is, where maybe you're a little bit unsure. Let's go on to number 2. Again, nothing is a power outside here. So we'll just multiply what we have here. So 2 times negative 4 is going to be negative 8. Again, these and this x all have a 1 as an exponent. X to the first times x to the first is x to the second. Y to the first times y to the fourth is y to the fifth. Here we have a negative 8, but that's just a negative number. That's not a negative exponent. So that's going to stay right where it is. We don't have to move any of them in this case. Okay, number 3, I believe we did this one in class, but let's kind of go through it anyway. So again, nothing as a in parentheses raised to a power. So we're just going to, when we use that product rule, when we multiply like bases, we'll add the exponents. Let's look at the numbers also. So I have a 4 here and a 4 here. 4 times 4 is going to be 16. X's is going to be x to the 5th. Sorry, you can hear my cat outside the door. Y to the negative 4th times y squared is y to the negative 2nd when I add those. Again, we want to have all positive answers. So we're going to have 16, all positive exponents in our answer. So 16 is to the first power, x to the 5th is positive. We're going to keep those. We'll move y down to the bottom to be squared. Okay, number 4 is our first one here that has a product to a power, right? A power rule here. So again, if you are kind of going along with this, pause the video for a minute and then try this one and then come back and see, okay? Your kind of hint before is, remember there's a 1 here as an exponent. So remember that when I have a power, this outside number gets multiplied by all of the exponents. So if we go ahead and do that, we're going to have 2 to the second power. 1 times 2 is 2. We're going to have b to the negative 6th power. We're going to have c to the 10th power. And we're going to have d to the 8th power. So just take a minute and make sure you see where all of those numbers came from. 2 to the second, b to the negative 6th, c to the 10th, d to the 8th, right? I multiply each of those. Just be careful because a lot of times I'll have people that understand this rule, but just kind of get off track. They'll start at going, and then somewhere in the middle here, they'll start adding by mistake instead of multiplying. So just make sure you're multiplying all of those. Again, we want to make our answer have only positive exponents. We can either leave this as 2 squared, or because it's a small number, we could just make it 4. It's positive exponent. B to the negative 6th, that's going to move down here to be b to the 6th. C to the 10th, d to the 8th stays up here. Now this was already in alphabetical order. Just a little note, generally we put our answers in alphabetical order. So if we had ended up with d to the 8th, c to the 10th somehow, we would have switched that around. It's not going to be wrong if you don't, but generally that's kind of the convention. Okay, let's look at number 5. So we have here a couple different things. We have d squared times d to the 4th raised to the 5th power. Remember, I always say that the exponents are kind of weak, so they only go with whatever it's right next to. So that 5 is going to go with this thing in parentheses here. This d squared is not raised to the 5th power. So we have d squared times d to the 20th, right? You do not need to have this little multiplication sign there. I just kind of put it in there to remind you that you're multiplying. Now, so I had d to the 20th because of the power rule. Now I have these two. I'm going to use the product rule because I have 2 different expressions that are being multiplied. Now I add those exponents. I don't have to change them to the bottom because it's a positive exponent. All right, I believe we did this one in class too, but we'll just go through it. Again, once you have something to a power using that power rule, I always suggest going in and filling in anything that does not have an exponent with a 1. Just so we remember, it is not 3 times 4, it's 1 times 4. It's 3 to the 1 times 4, which is 4th. B to the 4th. C to the 20th. B to the 2nd. C to the 2nd. Okay, so that's my first step. This expression was raised to the 4th power. This expression is raised to the 2nd power. Now I can go ahead and combine like bases, the terms with like bases. So I have b to the 4th and b squared. That's going to be b to the 6th, c to the 20th, and c to the 2nd is c to the 22nd. I can leave it like this, or since 3 to the 4th is relatively small, I can turn it into a number. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Okay, let's go ahead and take a look at the next one, number 7. So here I have 3 different exponential expressions. They're all just being multiplied. Nothing is being raised to a power. So we're just going to think about this as being the product rule, okay? So I can just add these. We're going to look at this a couple different ways, but first I can just add the exponents. -4 plus 4 is 0. 0 plus -5 is -5. So a to the -5th, which is the same as 1 over a to the +5th. Now you may remember in class, I said at some point that you have some kind of choice sometimes about what you do, what order you do things in. So let me just change the color here so it kind of stands out a little differently. So another thing you could have done here is you can, when you're dealing with exponential expressions and some of the exponents are negative, you can change those to positives if you want. So I could, from right here, say, okay, this is the same as, I keep that middle a to the 4th where it is, but this one and this one need to move to the bottom. And then, you know, I could either say it's a to the 4th over a to the 9th, and then subtract, or you can think that this and this actually just cancel out, right? Anything divided by itself. So I can see where that comes from. So either way, you're getting the same answer. Okay, let's look at this one now. Okay, this one is, as simple as it looks, probably just one step. We're using the quotient rule. When I subtract I top minus bottom, my answer always ends up on the top. So 5 minus 12 is -7. And then that becomes 1 over x to the positive 7th. Another way to think about this, if you think about kind of what we talked about, what's going on in the background. So on the top, x is being multiplied by itself 5 times. On the bottom, it's being multiplied by itself 12 times. I think I counted that right as I was talking. So I'm just gonna use a different color to cross them out. So if I cross out these 5, let's see, 1, 2, 3, 4, 5, yep. Then I have 7 left on the bottom and nothing on the top. But whenever you think about this, x goes into x once, x goes into x once, right? So really these are all ones being multiplied. So it's 1 over that x to the 7th. Again, you can kind of see where that comes from. All right, moving on. Okay, so number 9, we have 2 things put together here. We have the quotient rule and we have a power rule. You can do it either way. So let me show you, we'll do it both ways. Let's say first you're going to use the power rule. Okay, I'm just choosing that. So you know that this outside exponent gets multiplied by everything inside, every exponent inside those parentheses. So I would get m to the 6th over m to the 10th. Then I could use my quotient rule. 6 minus 10 is -4, which would be 1 over m to the 4th. That's one way to do it. Another way we can do it is we can take care of what's inside the parentheses first. We can do the quotient rule first. 3 minus 5 is going to be negative. Oops, I meant to change my color here. Okay, so let's take this out just to keep it easier to tell that this is 2 different things. Okay, well, it doesn't want to erase that. That's okay. All right, so we're inside the parentheses, we're going to have m to the -2nd power, 3 minus 5. This is still raised to the 2nd power. So in this purple case, I did what's in here first. In the red case, I dealt with that outside exponent first. So I have this, I'm going to have m to the -4th, and then again, 1 over m to the 4th. So often you can do things in more than one order with these, as long as you're following one of those rules. All right, so again, if you're, pause the video so you can try these on your own. Okay, maybe try a couple of them and then come back and check your answers. So let's look at number 10. I have the quotient rule here, so I can see I can combine those C's and I can combine these D's, right? When we have a quotient rule, we are subtracting. Whenever we subtract top minus bottom, the answer always ends up on top. So 3 minus 8 is -5. 7, now remember when I told you when you're dealing with negatives especially, write it out. So for our D's, I have 7 minus -1. That's like 7 plus 1, which is 8. I have D to the 8th over C to the 5th. Hopefully that part doesn't need a lot of explanation anymore. All right, number 11. So we have something to a power here. Here we have some sort of standalone expressions. You also notice that this is a special power, right? It's to the 0 power. So you could either think it's 3 to the 0, x to the 0, or you can just think about this whole thing being raised to the 0 power. That whole thing just equals 1. So I'm just writing out that first step without changing anything, just to sort of emphasize that. Okay, now we can just think 1 times 2, or just that 1 times all this is just going to be all this, right? So we have 2. We have to add 4 and -7 gives us -3. Okay, now here's something we have to be careful of, and we had talked about this a little bit, but my x to the -3 is going to go down here so it can be a +3. How about the 2? Well, the 2 actually has an exponent of 1. That is a positive exponent. So 2 is going to go stay at the top because it has a positive exponent. The -3 only is on the x. All right, let's look at 12. And again, you kind of get the lay of the land when you first get there. You can see there are no parentheses to take care of. There are x's, y's, and z's. So we're really going to be doing the quotient rule, okay? And then we have this 5 here that will just kind of hang out for now. So I'm dealing with some negatives. Let's go ahead and make sure we're writing this out. So we have -3 minus -2, right? -3 minus -2. That's like -3 plus 2, which is like -1. So x to the -1st power. Then I have y, 5 minus 1, so that's just 4. That's an easy one. And then z, we have negatives again. So 1, right? There's a 1 up here. Sorry, it wasn't a very good one. But 1 minus -4. That's like 1 plus 4, which is 5. And then once again, we're just going to change things around as needed to make all of our exponents positive. Remember that the 5 has an exponent of 1. It's positive, so I'm going to leave it where it is. Okay, finally, the last one we did do in class. Let me just go through it, though, in case you kind of forgot how it went in class or missed it, 'cause it's a little bit complicated. It just includes all the things we've already talked about, but it looks a little long. So the first thing we're going to do is get rid of these parentheses by using the power rule. So I have x to the -2nd. It's -2 because there's a 1 there, right? Y to the -6, oops, z to the +4. Then on the bottom, again, this whole thing is 1. Then I'm going to multiply all of these exponents by -3. It's not 2 times -3, it's 2 to the 1 times -3. It's the exponents that get multiplied. So 2x and y all had a 1, so they're going to be -3, z to the -12th. All right, now again, you can move things around. We talked about this in class. You can move things around so they're positive exponents, or you can just deal with the negatives. Just make sure when you're using the quotient rule that you are watching those signs. So for x, I'm going to write it over here. For x, I have -2 minus -3. That's like -2 plus 3, which is 1. So I have x to the 1st. For y, I have -6 minus -3, which is -6 plus 3, which is -3. And then for z, I have 4 minus -12, which is like 4 plus 12, or 16. And then I also, on the bottom, so these took care of the x, y, z, I have 2 to the -3rd. So if I move things around, I'm going to have 2 to the 3rd move to the top. So I always go through and say, okay, is it going to stay or is it going to move? This one's going to stay. This one's going to move. This one's going to stay. I already moved that 2 to the 3rd up. So I could leave it like that, or I could make 2 to the 3rd. Oh, hang on here. I can make 2 to the 3rd into 8 since that's a small number. So we have x, y to the 16th over y to the 3rd. Okay, we talked about scientific notation. I think we did the first one. This one would be 3.783, because that's how I would move the decimal point from here all the way in, to right here until there's just one number in front of the decimal. And then times 10 to some power. My power is going to be positive because I made a bigger number here. It's going to be positive 369 because that's how many places over I moved. I think we did the 472, right? So it would be 1, 2, 3, 4. I'd move it 4 places to get this number between 1 and 10. Since it's a small number, it's going to be a negative exponent. This one also, because it's starting out less than 1, we know it's going to be 10 to some negative power. So I move the decimal point 2 places to get 1.9 times 10 to the negative second. So standard notation, if it's a positive exponent, I'm going to move it in such a way that it makes a bigger number. So 4.73, well, my decimal starts out here. I'm going to move it 6 places, and I'm going to move it to the right because that's going to give me a bigger number. 1, 2, 3, 4, 5, 6. Fill in with zeros when I need to. So just to clean it up, it's 473 with 4 zeros. I go back and put in my commas. It's 4,730,000. Same idea here, 9.2. I know I need to move my decimal 3 places. If I move it this way, I'm going to get 0.0092. That's not a big number. So I'm going to move it this way. 1, 2, 3. Fill in with zeros, so it makes it 9,200. Which makes sense. 10 to the third is 1,000. So 9 times 10 to the third, 9 times 1,000. Okay, this one, this tells you you're going to end up with a little number. So we have 1.6. We want to move it 4 places so that we have a small number. So I'm going to take this and move it 1, 2, 3, 4. 1, 2, 3. Fill in with zeros. I usually put a 0 in front of the decimal also. It just makes it a little neater and easier to read. So 0.0016. So tenths, hundredths, thousands, thousandths, 10 thousandths, 100 thousandths, 1,600 thousandths. And same idea here. I start out with 8.123. I want to move it 2 places, but I don't want to go this way. I want to go this way so it makes a small number. So 1, 2. Fill this in with zeros. So 0.08123. Okay. All right, then we talked about radicals, different properties, and we simplified some of them. So we did these first few. For this one, I asked you to make this into a 6. So you can look back at the completed notes for that one. I think I remembered to record that class. I'm not 100% sure. But you can kind of look back at those. This one, I can't remember if we did this one or not, but think about, I asked you to do this one. And I said the hint here was you want to use the product rule for radicals and multiply what's in these. Because remember, it doesn't help us if we have a number here that's not a perfect square, which none of these are perfect squares and none of these are perfect squares. Let's go ahead and multiply. So 20 times 5 is going to be 100. We can multiply things that are alike. So we can multiply the x's. When I multiply the x's, I add the exponents. So it's going to be x to the 12th. When I multiply the y's, I add the exponents. I get y to the 8th. So these now are all perfect squares. As I said in class, I like to separate them out. Okay. So square root of 100 is 10. The square root of x to the 12th. Remember, if your exponent is divisible by your index, it's a perfect square. 12 divided by 2 is 6. That comes out of the square root. Think about what that means. X to the 6th squared means x to the 6th multiplied by itself. If I add those up, I get x to the 12th. Or you can think x to the 6th squared. Well, what would I do in that case? I'd multiply these by the power rule, so it does give me x to the 12th. Y, 8 divided by 2 is 4, so it's y to the 4th. Remember, there are no more square roots here because I took the square root of both of those. So I couldn't take the square roots when they was separate, but once I multiplied them together, they created exponents and number here that were a perfect square. All right, so I'm going to stop the video for now before it gets too long to be able to upload it. And then I will start another one for these last couple pages. Actually, pretty much just this last page. I guess there were a couple on the next one. Okay, I'll be back in just a minute.